Hey guys, welcome back to my channel. So today we are going to discuss another problem. Problem is search suggestion system. So in this problem we are given array of strings, products and a string search word. Design a system that suggests at most 3 product names from products after each character of search word is typed. Suggested products should have common prefix with the search word. If there are more than 3 products with a common prefix, return the 3 lexicographically minimum products. Return a list of suggested products after each character or search word is typed. Okay. So see, what does this mean? Let's take this test case. So in this test case, what we have, right? These are different strings, right? These are strings which is given to us. So what we need to do, right? These are some products, right? These are some products. We are also given a search word, right? In the input only a search word is given. So if you see here, the search word is given mouse. Okay. So this, what we need to do, right? What we need to do is we need to, whenever any character from the search word is typed, let's say first of all M will be typed, right? So suggestions should come, and there should be at most three suggestions. Okay. So see, if M is typed, these all words are starting with M, right? So ideally these all 5 should come in the suggestions, but we can only have at most 3 suggestions. So which 3 will be we'll choose from these. So see, if there are more than 3 products with a common prefix, this here, what is prefix? Here prefix is this M. Then what we will do, we will return the 3 lexicographically minimum product. So basically we will return those 3 which are, like, if you sort in ascending order, so those will come first. For example, this is OO. After M there is O, O, O. So O is same. After this is B. This is U, N, N, and U. So obviously this will come first. After that U, there is N. So N will come, and then N will come. U1 will not come, because if you sort these in lexicographical order, these 3 will come. So mobile, moneypot, and monitor. So mobile, moneypot, and monitor. Between this MON, how we are sorting these? This here is E, here it is I, right? So E comes first, so that's why moneypot is first and then monitor. Okay. After that, see, these 3 results were for the when we type M. So when we will type MO, okay. So when we will type MO, what will happen? For MOC, there will be this is also MO. This word is also prefix MO. So all have prefix MO. So again, we will sort on the basis of, like, all these 5 can be there, but we only need to have 3. So which 3 will have? Just a second. We will be having those 3 which are smallest in lexicographical order. Same, these will only come. After that, there will be MOU, right? There will be MOU. So MOU, this is not this string does not have prefix MOU. It has MOB. This has MOU. This also does not have MOU. This also does not have. This has MOU. So this and this will go in the suggestion result. That is mouse and mousepad. Similarly for S and E. Okay. So this is what the problem, right? One by one we have to take each character of the search word. Like first this M, this is a prefix, then MO is the prefix, then MOU is the prefix, MOS is the prefix, right? So this is how we have to take, and we have to return at most 3 suggestions. Okay. So I hope you understood the problem. Now let's see how we can approach it. So see guys, first of all, it is very clear, right? Since we have to return, if there are more than, see, if there are more than 3, right? More than 3 words which have the same prefix, words which have desired prefix, right? For example, mo. So mo all have mo. So then what we need to do, we need to return 3 lexicographical smallest, right? So for that, what we need to do, basically we'll have to do sorting. So this is clear that one approach which we can think of is using sorting. Okay, so if I sort this, right, if I sort this, what it will look like. So if you are, see, right now we'll be discussing the sorting approach. So if you know that approach, you can skip to the try approach. Okay, so see, when we will sort this, so it will be, basically it's sorted only. So it's sorted in ascending order from this to this. Okay, I think it's sorted only. No, it's not sorted. So this, yeah, this use coming. So if we sort it, it will be mobile, then it will be money pot. Okay, then monitor, then it will be mouse, and then it will be mouse pad. Okay, so after that, what we will do, we will, search word is given, right? Search word is given, which is mouse. So what we need to do, every time we have to take a prefix from this search word and search the suggestions. So first of all, we will iterate on this search word, right? We will iterate on this search word. First of all, we will have prefix. Our prefix will be m, single m character. So for that, what we need to do, we'll have to see in this, here this is sorted, right? So we have to search whether there is a word which starts with m or not, right? So do you agree on this? We have to start, we have to check whether there is a word which starts with m. So what we will do, we have to search. So there are two ways of searching. Either you can use linear search or you can use binary search. So here we will use binary search. It will also work with linear search. So binary search is more efficient, as we all know. So what we will search, right? We will search in this array, there is a word which starts with m or not. So we will get, let's say this is 0 index 1, 2, 3, 4. So we will get the 0 index, which is this mobile. So binary search will give us this index 0. Okay. So we got that. Now, but the thing was that we need to return at most 3 suggestions, right? If there are. For example, here only there were 2 suggestions which were matching the prefix, right? So at most 3 we have to give. So we will check, right? This is the starting of the prefix. This m, this is the starting word of that prefix. So since this is in sorted order, right? So this and this might also have that same prefix. It's not necessary, it might have. Okay. So we will check, right? The next 2 words we will check. So m is also there, m is there. So these 3 will be our output. Okay. So this is binary search approach. Let's discuss one more over here for one more prefix. Let's say we have MOU. Okay, MOU. We have to search for MOU prefix. So for this MOU prefix, right? We will binary search. We will find string. We will, what's the aim of binary search? We have to find a string which has prefix MOU. Okay. So what will the index by binary search, what index will be returned by binary search? This one, 3, because this MOU is there. Okay, so 3 will be returned. Now we have to check the next 2 words if they have MOU also. So next word is this mousepad, it has MOU, so this and this will be the answer, and there is no one after this word, so obviously we will go out of bounds, so we will not check for that. So these 2 will be the suggestions, like the products in the suggestion, mouse and mousepad. Okay, so this is binary search approach, guys, right? Now what is the time complexity for this? We'll go to every, right? First of all, we will get this prefix, then we go to this character, we will get mo prefix, then we go to u, we get mou prefix, right? S, we get mous. So first of all, we are traversing, we are iterating in this search word string, right? So that, let's say if it has length m, we are going m, right? And For each prefix, right, we are doing binary search in this array. So if let's say this array has length n, so m log n, log n for the binary search. So m log n will be the time complexity. Okay. Now let's quickly see the code once for this. So see, first of all, we are sorting. We have taken this vector to store our output. Okay. Then what we are doing, we are taking this empty prefix string. We are going to each character in the search word and we are adding it in prefix, and then we do the binary search to find out the index where like that prefix has the word which starts with that prefix, the first word. Lower bound will give you the first word. Lower bound is internally implemented using binary search only. So this lower underscore bound will give you the first word, right, which is equal to this prefix, basically which starts with this prefix. Okay. After that we will push it in the result, and then what we will have to check, like basically we'll start and we'll check for the next three words. Okay, this compare function will compare from this zero length to the prefix length. Okay, and what it have to search? It have to search prefix, the prefix which we are currently finding suggestions of. Okay, and now we are doing what this we are doing. This is we are updating the binary search start. Why we are doing this? Because see, if mo, right, if mo, let's say mou, okay, mou we are getting from this index, right, 3 index. Then then after that when we are searching for mous, why we have to start binary search from 0 index? Mou we got from third index, right? So mous we'll get from that or after that index, right? Obviously here we will not get, right, because mou we were getting from here. So that's why we, like, this is just an efficient, like, to make algorithm efficient, we will be updating the binary search start value to the last whatever the current start was. Okay, so this start index, this will return the start index. So I hope you are understood this approach. Just try it once. And now there is one more approach which is more optimized than this. So let's discuss that as well. So let me erase this. So guys, see, whenever you have to find something related to prefix, right? Like we have some strings and we have to find prefix. So one data structure which directly comes into mind is using a trie. Okay, because in trie we store every word, right? We can store every word, and we can search also. So whenever you have to find some words related, like having some prefix or suffix, right, you can think of using this trie. So what we have to do over here, right, what we have to do, we are given this search word which was mouse. We have to search this word, right? So basically what we have to search, like every time any character of this word is typed, we have to find the suggestions. So like m will be typed, we need to get some suggestions. Then mo, the next character mo, then mo, then the next character u. So this words related to these we need to find. Then MOUS, then MOUSE. Alright. So what we can do is we can make a trie so that we can easily find all the words starting with MO, all the words starting with MOD, MOU. Okay. So let's see how we can do that. How to make a trie, right? If you are not clear with the trie, like how to create a trie, I have created a video on it. You can go through that once. So it will come in the I button, or you can see in the description. So see, we will have a root. We have a root in the trie. So we will one by one insert all these words in trie. So first of all, we will insert this mobile. That is M O. So these all, right, this M O, these are trie nodes. These are trie nodes. Okay. So M O, then B, I, L, and then E. Right? Then we have to insert this mouse. So it will be M O U S E. Then we'll have to insert this money pot. So M O N E Y P O and T. Okay. Then monitor. So M O N I T O R, and then it's mousepad. So mouse. Here it will be PAD. But now see guys, how you will distinguish that there was a one word mouse and one word was mousepad, because they are in same, right? So whenever a word is ended, right, we have a boolean in that. So every this trie node, right, it has two things. One is the vector of children, whatever children this node has. Like this M has one children, this O has three children, B and U, and one has is end, right, is end a boolean. So which tells us that this is the this node is the end of the word. So here mobile E is the end of the word. So here for this node is end value will be true. For this L node is end value will be false, because this is not the end of the word. Okay, so I hope you got this. Similarly for this T also, is end value will be true. For this R also it will be true, because this is the end of the word. For this E, because mouse E is the end, so for this E is end will be true, and for this D is end will be true. Okay, so for the ones which I have marked with the blue circle, those, for those is end will be what you say, true. Okay, now let's see how we can, this is basically how to create a trie. So if you're not clear with it, again you can watch that video first. Now let's see how we can search for the suggestions. So first of all, we get M, right? We get M. This is a prefix which we have to search words of, starting words with. So prefix is M. So what we will do, we will find this M. Okay. Now we have different possibilities. We can go find this also. We can find this also. So we have to have at most three, right? At most three. So from this M, right, we will traverse on its children. So M has only one children. From this O, we will traverse to its children. Like this we will do. This is what we are doing, depth first search, right? Depth first search. We just go to the children. From L we go to E. And now we see E is the end of the word. So we got one word which is mobile. So we got one word which is mobile. Okay. Similarly, what we will do, from this O, we can go to B. Instead of going to B children, child, we can go to N child also. So then we will get B M O N. From now, see, from this N there are two possibilities. In order, like, you can go to E also, you can go to I also. So first you go to E, because it comes first in the alphabet, right? So then you will get this money pot, and then from this N you can go to I, so you will get monitor. So we get three words, right? One is this mobile, then money pot, and then monitor. So we will not go any further. So see, from this rather than sorting, we are using trie, right? So obviously the answer will be sorted, because in trie we go alphabet wise. First, if you have to go from O, first you will go to B, then you will go to N, then you will go to U. Okay, now let's try for one more prefix. So let's say we have MOUS. Okay, we have MOUS. So MOUS prefix we need to search. So first of all, we will check whether there is some prefix, like whether there is this prefix, any word which have this prefix or not. So M. So from this M, where we have to go to O child. So we will go to O child. From this O child, where we have to go to U. So we will see, is there any U child? Yes, there is. Then we go to S. We will see whether from U there is any child S. Yes, there is. So it's confirmed that there will be a word starting from this prefix. Now we can find that word using depth first search. Right. So first from this S we will go to E, because there is only one option to go to E. Now we will see that this E is the end of the word. So one word is what? Mouse. Then we'll continue. So then we'll go to P, then A, then D, and we will again see, okay, this D is the end of the word. So another word which we get is mousepad. And now there is no further children, so we will stop. So this is approach, right? This is try approach, guys. I hope you understood it. It's very easy. Just you need to know how to create a try and how to traverse in try. So let's see the code for this. Okay. So this function, right? This function is given to us suggested products, and we will get the list of products and the search string. So what we need to do? First of all, we have to this try node we have, right? Try node, it has the children array. Initially, every children, like for each node, there will be no children, so null is there in at every place. And end of the word boolean is false initially. Okay. Then what we will do? We will here we will traverse in each product, and we will insert it in the try. So insert word is a function to insert a word in the try. So insert a word. Okay. So this is the code to insert a word in the try. Okay. After that, after inserting the word, we'll have to check for each prefix, right? So we'll go to each character in the search string. Every time we'll update the prefix, and we will find that whether there are suggestions for that prefix or not. So search word is a function to find that. So we go to search word. First, if you remember, what we did was we did check whether there is any word with this prefix or not, MOUS. So here we are going to each character in that prefix, and whether we are checking if there is any, like if any at any time there is no children. Like for example, let's say there was no, after this MOU there was no S child for this U. So then there will be no word starting with this prefix. So that we are checking here. And once it's done, so our try variable will be here. And then we can just DFS till the end. DFS. This try address will be the this next address. Like till after the prefix, the next node. So DFS, if the total suggestions, like total words are 3, then we just return, because we can at most return 3. If it's the end of the word, just get that, because that will be one answer. Otherwise, go to each children if there is, and just find the words. Okay. Why we are adding this the character? Because we have to build the string, right? We have in the prefix, we only have till MOUS. This E we have to add. After that, we have to add this P. So this is what we are building here. So I hope you understood the problem and the approach. Let me know in the comments if you have any doubt. If you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video. Thank you.